Hey members, not every function that is continuous is differentiable at that particular point, but all functions that are differentiable at any particular point, they are also continuous at those particular points. In this lecture, we discuss a number on how we can test for continuity and differentiability at x is equal to 2. Now, f of x is equal to this x squared minus 3 for values of x less than 2, and f of x is equal to 4x minus 7 for values of x greater than or equal to 2. So let's begin with continuity test. So since we know that for this function to be differentiable, it has to be continuous first at that point x is equal to 2. So let's test for continuity. We know that the limit as x tends to c for f of x, it must exist, and here c is equal to 2. So the limit of this function at x is equal to 2, it must exist. And we know that that limit will equal to limit of f of x as x tends to 2 must equal to the value of the function at x is equal to 2. So let's proceed and we look for this limit. Now, since this is a piecewise function, we are going to approach x equal to 2 from the left and from the right. So let's limit x is equal to, as x tends to 2 from the left for f of x, okay, x squared minus 3. What will this value equal to? This is going to be 4 minus 3, and that is equal to 1. Then we are also saying limit as x tends to 2 from the right of f of x, whereby that function now is 4x minus 7. This is equal to 4 into 2 minus 7, and this is equal to 1. So this is showing us that limit, okay, as x tends to 2 from the left hand side of f of x is equal to limit of the function as x tends to 2 from the right hand side of f of x is equal to 1. So that means since they are the same, these two values are the same, the function is continuous at x is equal to 1. So immediately, always look for the value of the function, okay, the value of the function at x is equal to c, or at x is equal to 2, which is given. Then limit the functions, limit this function as you approach 2 from both sides, the left and right. So since we have already seen that the function is continuous at x is equal to the x is equal to 2, okay, then let's look at differentiability. So this function can either be differentiable or it may not, okay, since continuity does not guarantee differentiability, but differentiability can guarantee continuity, meaning this function could be differentiable or may not. But let's go ahead and test. So what we are going to do is to look for, limit as x tends to 2 of the first derivative of f of x. But let us approach x is equal to 2 from the left. So this is the same as if we differentiate the value of f of x, I mean the function f of x from the right, I mean from the left, this is going to be 2x minus 0. So this is going to be the same as limiting x tends to 2 from the left of 2x. Yes. So let's put in our value. This becomes 2 times 2, that is equal to 4. Let's also look at limit x as x tends to 2 from the right of the first derivative of f of x is the same as limiting x tending to 2 from the right hand side. Okay, what's the right hand side of f of x? We have there 4x minus 7. If we differentiate that, we will get 4. So 4, this is equal to 4. So since it is equal to 4 and limit as x tends to 2 from the right of f prime of x, we are finding that it is the same as limit f prime of x as x tends to 2 from the right hand side and is equal to 4, then the function is differentiable at x is equal to 2. Yes.